Hi, Chris Good here, and we're going to do problem number 3. Now, I've already put the data in here. Let's read what the problem was. You notice that the entire population of Rhode Island seems to be influenced by what they eat. You randomly assign half of them to eat fruit and measure how many kites they fly. Okay, so we're measuring kite flying behavior in Rhode Island. How bizarre. Alright, so we've got people who ate fruit, randomly assigned to eat fruit, people who randomly assigned to eat no fruit. Let's, is there a significant effect of fruit? And what is the nature of that effect? Let's do all our null hypothesis testing steps. So, state the null hypothesis, HO is that mu1, HO is that mu1 minus mu2 is 0. Can't do the t-test without it. We'll use, as usual, an alpha of 0.05. And we can look up our t-crit because, as you can see, I've already got our pooled degrees of freedom here. And we put that in parentheses after t-crit. And then we'll go to the data table. Here we are in our favorite column, alpha of 0.05. By the way, if we want to do alpha of 0.05 in a one-tailed test, we'd use this column. But we want two tails, so we'll put 0.05 there, and we'll use 12 degrees of freedom. That means 2.179, and it's two-tailed, so we will write plus or minus 2.179. All right, and we'll go on to calculate t. You know what? I forgot. In the past two problems, I forgot to write this. We could do this. Alpha 0.05, let's put an equal sign there. Alpha equals 2.05, two-tailed, and then the t-crit is right there. Okay, good. Let's go to calculate t. Let's go to our handy formula sheet. And for t, we have the means. I already put the means and the ends and the degrees of freedom up here. And we know mu1 minus mu2 equals 0 from the null. And we need the estimated standard error, which means we need pooled variance, which means we need sums of squares. Let's do this sums of squares the old-fashioned way. All right, so we're going to, first of all, make us a little bit of room here. And then I need a couple more columns to do deviations, and then deviations squared. Copy this and put it over here too. Okay, what is this deviation? Is this one minus the mean, but I want to make that a static reference to the mean. So it's always going to reference that cell. We'll copy and paste this down here. Those are the deviations. Square that to get squared deviation, and we'll sum those squared deviations here. Not sum squared deviations for 1, and sum of squares number 2 is going to go over here. So let's deviate this from its mean, which was 8, right? But I want it to always be cell E13, even when I copy and paste here. All right. We'll square that. And then we'll sum these squared deviations. Seems like it's easier in Excel to sum squared deviations this way than to use that computational formula, but could go either way. I'll show you how to do it in problem 4, maybe a little simpler, all in one equation. All right, we've got our sums of squares. Let's align these right and then bold them so that we won't lose track of them. Bold them. Thank you. All right. We can do pooled variance now as our sums of squares divided by our degrees of freedom added together. And make sure you get those parentheses right. If you do parentheses anywhere else, you won't get it right. Now we can do our estimated standard error. This is the harder one. So this is the square root of, and then another parenthesis, pooled variance divided by n1. What did I do wrong? It's the square root of, and then in parentheses, pooled variance divided by n1 plus pooled variance divided by n2. Close, and then close them again, and so we're taking the square root of this entire thing. Let's just see what we're doing here. So b20 over b11 is pooled variance over n1, and that's got to be done in parentheses because we need to divide that first, and then we add, and then we need more parentheses to get this part. It's the same b20 for pooled variance, and I'm referencing e11 to get n2, just like the sheet is showing us. And then that entire quantity in parentheses pooled variance over n1, then plus in another set of parentheses pooled variance over n2. That entire quantity is also parenthesized to follow the square root function, which means we're taking the square root of this entire quantity after we first divide, then add, then take the square root. All right, you should get this. That means that t is equal to the difference between our two sample means, mean 1 minus mean 2. Now, I mean, technically we'd subtract mu1 minus mu2, but that's always going to be 0 because of the null hypothesis. We're going to divide that mean difference by the estimated standard error of the difference between those two means. So t is negative 0. You know what? That's a lot of decimals. And I'm going to let Google Docs round them properly. Okay. There we go. There's our t value. It's time to make our decision. Well, the question is, what was the question? Does fruit affect what was measured? How many kites you fly? Well, let's go back to the statistical table and check out where this is. What was our critical value? Plus 2.179, that's here. 0 is at the center. Minus 2.179 over here. Where is negative 0.994? Well, 0's here, right? We'd go negative 1, negative 2, negative 2.179, and along the way we passed 0.994. Negative 0.994 is below 0, but it's not that far below 0. It's not into the critical region. And so you see that we cannot reject. We fail to reject the null. We'll retain the null. What does that mean? Well, let's go back to the question. What were we trying to know? Is there a significant effect of fruit? So we can say that people who eat fruit do not fly significantly fewer kites than people who do not eat fruit or who did not eat fruit. And then t at 12 pooled degrees of freedom was negative 0.994 with a p. Well, what was p? We don't know what p was exactly, but we know that 5% is in two tails combined, and our p wasn't in that 5%. So p is the proportion of area under the curve beyond negative 0.994 and above positive 0.994 because it's a two-tailed test. We don't know what p is, but we know that it's the area beyond this plus the area beyond this. We know it's greater than the shaded area, And we know that the shaded area, there's 2.5% over here, 2.5% over here. So we know that P is greater than 0.05. Now, technically we would italicize T and P to be in proper APA style and put a period after 0.05. And that is a nice summary for problem 3. I'll be back in a moment with problem 4.